Hi everyone, a warm welcome to the part 3 of this webinar series around the Async webinar. Today we talk about Async 08 and the new NServiceBus V6 API update. Again, I'm Daniel. I'm a solution architect for particular software. I live in central Switzerland, and if you want to know more about me, I suggest you listen to episode 77 of the Developer on Fire podcast. You can reach me on Twitter under @Daniel Marbach. I blog on the particular blog and on my personal blog. So I have to tell you a little secret about me. Every time I feel I need something to cheer me up, I'll take a piece of Swiss chocolate. You might wonder what chocolate has to do with NServiceBus V6 API update and especially Async 08. Well, let me tell you a sweet but totally fictional story. Switzerland is well known for its excellent chocolate bars. From day to day, the international demand on these excellent chocolate bars is actually rising. The Swiss chocolate bar manufacturers realized that they need to build a highly reliable chocolate control and supervision system to be able to cope with the high market demands. The engineering team that was responsible to build that system decided to use a distributed architecture since the nature of the chocolate manufacturing process seems to be a good fit for that. One of the secret ingredients their factory are using is vanilla. According to the Federal Act on Foodstuff and Utility Article 817, additives such as vanilla need to be tracked during the manufacturing process. Over the years, vanilla as an additive for chocolate became so popular that the Swiss government introduced a nationwide vanilla service to control the vanilla acquiring. Vanilla as an additive is so popular that this service provided by the government was used more and more, and the reliability of this service really decreased. Someone in the team argued that NServiceBus would be a really good fit to introduce reliability when calling this government service. Others in the team said that Swiss-made should actually be indication enough about the robustness and the reliability of these solutions. After long arguments back and forth in the team, they decided that Swiss-made is enough for reliability, but probably not enough for scalability. So they built their first system with NServiceBus. So I visualized here quickly the process of chocolate manufacturing. The chocolate bar processing workflow is managed by the chocolate bar producer policy. That's indicated here. If you're not familiar with NServiceBus, don't worry. I will briefly show it in code and briefly scratch the surface area of the concept of NServiceBus later. The policy gets started as soon as the produce chocolate bar command is issued, indicated here, by the facility itself. The first step in the process is roasting, visualized here. During the roasting process, the cacao beans get smoothly roasted. The step starts with the roast beans command and is finished as soon as the beans roasted event is published. The events are not visualized here on this diagram. The next step after the roasting is the grinding process, where the beans get ground and eventually liquefied into chocolate liquor. Depending on the chocolate bar, the grinding process produces cacao solids or cacao butter. When the process is finished, a beans ground event is published. The last and the final step is the blending process, indicated here, which gets started with the blend chocolate command. During the blending process, vanilla gets acquired, tracked, and the chocolate bars get produced. The whole process is done when the chocolate blended event is handled by the chocolate bar producer policy, indicated here with this box. So let's get not hung on the details in the slides and quickly switch over how this running system looked like that the team produced. Allow me to switch over. 1 second. Here we have the beautiful website that the Swiss chocolate manufacturing team made. And we can see here we have a produce chocolate button. We have a few background processes here on here we have the blending process. On the right side we have the facility. Down below we have the roasting. And here on the left side below we have the grinding process. So let's start a chocolate production. I click the button, I click it twice, and as we can see, the services behind the scenes, they start blending, roasting, and grinding. And as we can see here on the top left corner, we acquired vanilla. Then we are polling the government service until we get the vanilla. We save the vanilla statistics. And in the end, when everything is done, we have chocolate blended. So this time, because I hit the button twice, we essentially have two lots. The one lot is 3003 and the other one is 6933. So we just produced two chocolate bars. Let us see how this looks like in code. Let's switch over to the chocolate manufacturing. Let us start with the home controller. This is the entry point into the chocolate manufacturing process. As we can see, we have a send-only bus. A send-only bus is a bus which essentially doesn't have a message pump. So it's not able to receive messages. We create an entity framework context. We send a command over bus.send to the background systems, and then we save some information into the database, and basically that's it. On the other hand, we have policies and handlers that are handling these commands and the events that are happening in the system. So let us, for example, briefly explore the acquire vanilla handler. As you can see, in order to handle a message, we implement iHandleMessages of T, and T is the message. So here, acquire vanilla. We have here again our beloved iBus object, and as we can see, the handle method receives an acquire vanilla message instance, and then we acquire vanilla from the government service. We open a transaction with entity framework. We record the usage of vanilla in our database, and then we use bus.reply to reply back to whoever who sent us this acquire vanilla message. And then we save everything on entity framework and we commit the transactions. So that's basically it from a usage perspective. On the other hand, we have the coordinator, or like I call it, policy. The policy here is an NServiceBus Saga. The NServiceBus Saga here is started when we receive a blend chocolate command, and it gets correlated back when the vanilla acquired reply message comes in. And as we can see, for the blending process, the blending policy is just handling the blend chocolate message and is done as soon as we have everything acquired, and then it publishes the chocolate blended event. So that means we know now that a chocolate bar is successfully produced. On the other hand, we have the top coordinator, which is responsible to coordinate the whole chocolate bar production process. This is called the chocolate bar processing policy. Again, it's a saga. For those who haven't used NServiceBus before, the difference between a saga or a policy and a message handler is just that the saga keeps state around and message handlers are stateless. So as we can see, as soon as we handle the produced chocolate bar, we assign the lot number of the currently produced chocolate bar, and then we start the process by sending in a roast beans. Then when we have the beans roasted, we send in the grind beans, and when we have the beans ground received, we send in the blend chocolate, and as soon as we receive the chocolate blended event, we mark this whole policy as completed, and we know that the process is done. That's basically everything here in this solution with NServiceBus version 5. Let's go back to the slides. So the Swiss chocolate manufacturing totally underestimated the high demand on the delicious Swiss chocolate bars, especially around Christmas and Easter season. Since they were running the system on-premise, it was not really possible for them to elastically scale up and down their chocolate control and guiding system, including the front ends, the customer-facing portals we've just seen. The platform as a service offerings from the Azure cloud seemed to be an answer for all their problems. So they started migrating over their existing NServiceBus system to the platform as a service offerings by the Azure cloud. This also meant the team actually wanted to use the other platform as a service offerings like blob storage, DocumentDB, and so on. So previously, as we have seen in the code example, the handler looked like really simple and straightforward, like the handler I show here on this slide. But the problem was, in the cloud environments, the code drastically changed. So in the cloud environment, the code looked basically like this. The APIs provided by Microsoft were mostly asynchronous only. This started to get slightly cumbersome for the team members. Someone in the team wanted to get rid of these result.wait calls because they argued that every time an exception is raised by these APIs, the original exception is masked behind an aggregate exception, as we learned in previous webinars. And they also argued that with these blocking calls, it was not really possible to leverage the true asynchronous nature of these cloud-enabled APIs. So they decided to start refactoring this code from these blocking calls to use the async await keyword. So the code then started to look like this after they rewrote everything to async await. So as you can see, instead of .result and .wait, they just wrote here await in front of the calls. But the problem was, this code didn't really compile. When they compiled the code, they got this compiler warning. Error 4033, the wait operator can only be used within an async method. Consider marking this method with the async modifier and changing its return type to task. Well, nothing simpler than that. With ReSharper, just enter all the things, shall we? Let's do that. As we can see, the handler now changed to async void. We fixed it. Cool, it compiles. Let's do continuous integration, continuous deployment to the cloud, and done. It's beer o'clock. We can go home. Awesome job, team. One day, a really angry customer called in because their custom-made chocolate bar order submitted 2 weeks ago never arrived. So the project managers in the project really got angry and told the team they should investigate as quickly as possible what the root cause of the chocolate order loss could be. After days of investigation, someone from the team was able to trace the root cause down to this vanilla handler. Apparently, this was the weak element in the system, but why? So let us explore the analysis of the team with a few slides. So let's go back to traditional handlers. With a traditional blocking version of a message handler, the message is arriving into the queue. It gets picked up by the message pump. We saw how a message pump could look like in the previous webinar. And the code is dispatched to the handler. The handler execution time is the sum of all blocking operations. When all operations are successful, the message is marked as successfully processed and removed from the queue. As we can see, the message is green, it's removed from the queue. But what happens in error scenarios? So in error scenarios, when we have a message in the queue, we dispatch to the first method, to the handler, to the first method, to the second one, and now an exception occurs. Since we have the wait calls, an aggregate exception is raised and propagated back to the NServiceBus infrastructure to the message pump. The message is marked as not successfully processed, indicated here with the red color on the envelope, and the message is retried until it's successful, or if it's not successful after multiple times, the message is moved back, is moved into the error queue. But what happened with the async void variant of the handler? Well, let's see what happens. The message arrives in the queue, we dispatch the message to the handler, and as soon as the NServiceBus infrastructure reaches the first await keyword, then for NServiceBus, the message is marked as successfully processed and it's removed from the queue. Well, that's all fine as long as everything is successful. But when it's not successful, then the following happens. So let's see. The message arrives in the queue and we go into the first await statement. Everything executed before the first await statement is still executed synchronously. Therefore, it's possible to observe any exceptions being raised before the first await statement. And when we go into the first IO completion port of the await statement, then for NServiceBus, the call is over. So what happens, we mark the message as successful, it's removed from the queue, but anytime later, since the code is still executing, remember, async void is essentially fire and forget, the exception is raised somewhere in the background, but still the message is successful. As I told you in the last webinars, async void is evil. And as we can see here, this has real consequences. When we use async void, for example, with handlers, with NServiceBus version 5, we would essentially lose, like here, orders in production. So the analysis of the team showed that the NServiceBus version 5 engine is not really built for asynchronous code. I mean, it would be technically possible to intercept the exceptions raised behind the scenes, but to truly benefit of the asynchronous APIs in the cloud, they could still not be used with the version 5 of NServiceBus. So, as we've seen in the code written by the team, Microsoft and the community is all moving their APIs to IO-bound, like the Cloud APIs and the Azure SDK, to async await enabled models. In fact, for Microsoft Windows 8, the API guidelines state that all IO API calls taking longer than 50 milliseconds should be async. So as we can see, async await has matured and it's widely adopted even outside the .NET distortion field. For example, ECMAScript 7, they're talking in their specification about adopting the async functions and keywords. Dart already adopted it. Go has it as a notion of coroutines, and Python as well. But even more important is the fact that the NServiceBus core domain, like queuing, persistence, and even your code, as we've seen before, usually calls into databases, web services, and so on, is all about IO operations. To properly support async scenarios, we had no choice but to rewrite NServiceBus entirely to be fully async all the way up and down, as we discussed in the previous webinars. So let's see what that means for the handler code. Now with NServiceBus version 6, the iHandleMessages interface returns a task. So this allows you to await the asynchronous APIs by marking the method as async. So far so good. But let's see. And finally, you can await all operations in your handler. So the biggest strength of this API changes becomes really apparent when you look at the composability of the async APIs. So for example, let's assume that each of them, here, here, and here, takes roughly 5 seconds. So the total execution time of this handle method will be roughly 20 seconds. If we call await sequentially, but as we learned in the previous webinars, we don't have to. So with the new API returning a task, what we can do is we can assign the task returned by these methods to local variables, and then we return a task which captures the first one, the second one, the third, and the fourth one. So the handle method here would only be completed when this combined task of these 4 tasks is completed. But since they can execute now concurrently, instead of being sequentially executed, we can essentially cut down the execution time of this handler to approximately 5 seconds. But what is the implication of this API design change for message handlers and messages when we have an exception? So let's visualize again what happens with the new API when a message arrives and there is an exception in the code. The message arrives, it's dispatched to the first await statement, to the second, the third, and let's assume the third one throws an exception. So what happens is, since the underlying state machine that is generated by the .NET framework captures all exceptions raised in the task object and floats it back to the caller, NServiceBus can intercept that exception, see that exception, inspect it, and then it knows that the message processing was not successful, and it can move the message back into the queue, or if the retry fails, back into the error queue. So what that means, with the new API, we don't lose the messages anymore. But of course, there are not only asynchronous handlers out there. Sometimes you just want to write something synchronous inside a handle. And now with this new API, you're essentially forced to return a task every time. Well, that's not a big deal because it's really, really simple, as shown in the previous webinar, to write synchronous code into an asynchronous code. Let us see an example. So what we can do here, as a first step, we just write our synchronous code into the new handler API. As we can see here, it returns a task, we just do something synchronous. Unfortunately, then we can mark it, for example, as async, but the problem is, if we do that, we then get this compiler warning. This async method lacks await operators and will run synchronously. Consider using the await operator to await non-blocking API calls or await tasks that run, and so on. So we could, of course, suppress these compiler warnings, but I mean, suppressing compiler warnings can have severe consequences. So we could be missing another bug hidden in our code by suppressing this compiler warning. So I suggest we just use another approach. The better option is, when you execute synchronous code in your handlers, you just do something synchronous and then you return task to complete the task if you're on .NET 4.6, or you return task from result 0, false, true, or 1. Best practice is task from result 0. And that's basically it. There are a few other caveats you have to watch out when you're using NServiceBus version 6 and async await. One of these caveats is you have to check your code base for hidden, what I call ambient state. An ambient state is state which is accessed behind the scenes and not directly exposed as a first-class citizen on the API. An example of an ambient state could be a usage of thread static or thread local. I'm going to show in the demo such a usage. If you want to know more about ambient state, I suggest you read my blog post, The Dangers of Thread Local, on the particular blog. But you also have to watch out for usages of inversion of control container magic like per thread scope. Make sure that you change these scopes to container scoped. Or even better, redesign your APIs to float the state explicitly around in your code. I'm going to write a series of blog posts about this topic, and they will be published on the particular blog. So I suggest you follow the particular blog. So part of the async work we did for NServiceBus V6, we also applied these principles. So we tried to float state around. So that means we didn't suffer from multi-threading issues anymore. And a natural progressor of this design changes is what we now call the handler context. So the handler context is the communication object to the bus, which is now floated directly into the user code. So let us see how this handler now looks like. So as we can see here with the vanilla handler, so the iHandleMessages interface not only receives the message instance itself, but it also receives an iMessage handler context. The iMessage handler context interface provides all the communication methods for you to publish, send local, and so on. So there is no longer the need to inject property injection or constructor injection of iBus. The bus, the scope bus, which is responsible, which also has all the required information for the message that is currently being handled, will be passed into the handle method. This is also much simpler to unit test. So I'll show you briefly how the code would look like with NServiceBus version 6. And in order to do that, I have a solution which is still on NServiceBus version 5, and I will live migrate this solution to the NServiceBus version V6 latest unstable API. So let's do that together. So as we can see, the interface changed. So we have now here iHandleMessages. I quickly delete that. So in order to properly migrate, I first mark this one as async, then I copy paste all the code from the previous handle method into here. I'll delete all this code above, and now I replace all the usage of bus with context. And as we can see, because these methods, they return a task, and I have marked this method here as async, the compiler already tells me that I should await this send local call. So let's do that, and also await this one, and also await this context.publish. So that's it. We just live migrated in a few seconds a message handler. Let's see the implications for the home controller. So the home controller previously received an iSend-only bus. Today the communication object towards the bus is called iMessageSession. So let me change this code. Let's rename this one for better expressibility to session, this one as well. So I renamed this code, and now we can see that we have here send, which is returning a task. So I would like to await here. What I can do now is, since ASP.NET also allows us to write asynchronous code inside the controllers, we can just do task of action result here. And now we can mark this one as well as async, and that's it. So of course we're also using Entity Framework in here. Entity Framework itself is also async enabled. So if we want to also now combine our asynchronous send calls with Entity Framework, we can refactor this code to use the async APIs of Entity Framework as well. Now we really benefited, even in the controller code, for all I/O enabled APIs from the new async APIs. So we now migrated also this controller code. But of course, since previously we injected something else into the controller, this has also implications on the configuration. Let us briefly see. So instead of bus configuration, we now new up an endpoint configuration object. Instead of doing bus.create send only, we mark on the configuration this one as send only, and then we just use the endpoint, and there is a method called start. So we start an endpoint, and since we return this one, as we can see here, we're getting in an iEndpoint instance. So we return an iEndpoint instance, and since we want to do something asynchronous, because we have here a task returning API, we need to write here await, and of course that means for us we need to return here a task of an endpoint instance and mark this method as async. So now this one is also async, and since I wrote a simple type resolver, dependency resolver, we just have to change this one to from iSendOnlyBus, as we can see here, to iMessageSession, and then pass this into the controller, so you can see here. And since the iEndpoint instance is also implementing iMessageSession, we're already done. Of course, this has a few implications for the calling code, but I'm not going to dive into this right now. Let's see another handler in our infrastructure. Here we can apply the same refactoring steps. So we just implement, again, the new method. We copy-paste the previous code into here. Again, we mark this one as async. We delete all the previous code. And we replace the previous bus usage with context. And now we have to await this reply here. And since we can now also leverage the async APIs for entity framework, we can just introduce save changes async here, and that's already it. Well, another thing we have to briefly talk about is that I mentioned before that we have to look out for ambient state. So let me look around here in this solution. As we can see here, we have a communicator object. The communicator object here is responsible to create the necessary proxies to communicate with the government vanilla service. So it's using here a thread local. So how can we get rid of this thread local? So one thing we can do is we can introduce a constructor here and passing in the factory object. So let's do that. Let's get rid of this one. Let's get rid of the thread local since we don't want to use thread local, as I told you that it's dangerous. So we remove the static. We assign this here to the factory passed in, and we start using this factory here. So let me briefly remove that one, and let's use the field here. So we just refactored now this piece of code. To use this vanilla factory, of course, I should write compiling code. So that's it. So now, since we're no longer using thread static, what else can we do? Let us see how we register the dependencies. So as we can see here, we have here, for example, I'm using structure map here. As we can see, we now have to register the dependencies of this communicator here in this structure map configuration. So one way we can do this is by leveraging what structure map, for example, calls container scope. So here, what you can do is we can say, okay, if anyone requires a channel factory of iVanilla service, we will be providing a new channel factory of iVanilla service with the required bindings, and we set the lifecycle to container scope. Since NServiceBus still creates a new child container every time a message is handled, that means we get, per message receivable, we get a new channel factory. So we now have scoped the channel factory to the message instead to threads. And of course we have here another thread local, which we should no longer be using, and we can here switch to also container scoped. So that means the entity framework vanilla context will also be scoped to message receivable, and therefore we get a new context every time we receive a message. So now we got rid of all ambient state in our software. We also got rid of all container magic, like the thread scope. Yes, we're now using the container scoped, but this is much more safe when we are using async await and the task-based API than relying on per thread scope. So let me switch back to the slides. So as we've just seen in this live coding demo, the migration for synchronous but also asynchronous code is straightforward. Large portions of the migration process I just showed here manually can be automated with code helpers and templates. And make sure you consider our upgrade guides on the docs.particular.net website. And of course, I mean, if you really want to embrace the full potential of async await in your code, then your code should change as well. So it should no longer be synchronous, but it should be asynchronous. I'll briefly give you a hint how you can already prepare yourself for NServiceBus V6 if you want to fully embrace the new async APIs. You can do that with the following code. So if you already use async await enabled APIs, you can write the previous iHandle messages from version 5 with void handle, and then you write an handle internal method. You pass in the message, and you pass in the iBus instance and call it context. You mark it async task, and you have here your await statements from your code, and here your bus operations from V5 which are not async enabled. And then what you do in the top handle method, you call handle internal.getAwaiter getResult. This will make sure this code is executed in a blocking fashion, but will unwrap all the inner exceptions raised here and will not raise the aggregate exception as we discussed before. And when we move then to version 6 of NServiceBus, you just essentially inline this method. And since this method is already marked async, when you will be using the new iMessageHandler context interface, you get compiler warnings for the methods here that now return task objects. So this is a really nice way to prepare yourself. So as we've just learned in this webinar, technology and frameworks are evolving. So they are evolving like the cars when we went from gas to hybrid solutions, like visualized here with this amazing Tesla car. This is a natural progression in the software industry. So the new engine of NServiceBus V6 is built for asynchronous code and makes your code faster and more composable, and therefore it also increases the throughput of your messaging. With V6 there are also many more changes I'm not discussing here in this webinar, but we are fully async all the way up and down. The code I just showed you, the slides, the links and everything can be found on github.com/DonnyMarbach, and here's the URI. We will also send this out in a separate email to everyone. And now let's go to the questions and answer section. Sean, any questions so far?
Yeah, we have one question from, I'm sorry, I'm not sure that I'll pronounce the name correctly, but it's Blaze Bright or something like that. And he says, why is thread scope not advised? I didn't get it yet. So he's asking, can you repeat the why the thread scope local is dangerous?
So to answer this question, I suggest he reads the Danger of Thread Local blog post, because there he gets a detailed explanation, including code he can execute on his local machine. But the basic is, like we learned in the previous webinars, with async-enabled APIs, we no longer talk about threads. We talk about tasks, which can be IO-bound or CPU-bound. Here there are IO-bound. So that means for every await statement, the calling thread from our message pump can go back and do some other work. So as we can imagine, that means multiple threads could be handling the code which is written inside the handler. So therefore, if we use thread local, we would essentially or potentially get multiple instances created of this channel factory. And therefore, we would have unpleasant surprises, because we would assume that we would just use one channel factory per message receiver, but sometimes in production we would be using multiple and therefore wasting unnecessary resources. But that being said, I suggest to to look again at the first webinar where I explained concurrency and parallelism and I/O bound versus CPU bound on the second webinar from the task APIs, and also read my blog posts to get more details.
Cool, that makes sense. Okay, another question from Miguel. He says, when should I use the async and await keywords instead of the NServiceBus publish subscribe pattern?
Okay, we had this question also in a previous webinar. So, well, the answer is, unfortunately, it depends. So what it means is that if you divide, for example, let's go back briefly to this code here. Hold on a second. Okay, let's see. So let's go back to this code here. So let's assume here we have, in my example, we have everything in this handle method. So what it means is that everything inside this handle method shares the same, let's say, transactional boundaries. Of course, we can take a conscious decision in our designed architecture that we want these operations to be separate individual operations which can fail and can be handled separately. So what that means is we could replace this code by just sending out 4 messages and handling those 4 messages on different endpoints and handlers. So yeah, the answer is it depends on your design decisions. But what it means is that yes, all these operations are now no longer tied together, which might be desired or might not be desired. Does that answer the question?
I think so. If I understood the question correctly, I think it answers the question. There's another one, is it Victor asking, can you use the new iMessage session instead of full iBus when I do self-hosting on NServiceBus, like a website?
Yes. Yeah. iMessage session is the object which is exposed on the endpoint level. So when they do self-hosting, the endpoint instance is implementing iMessage session. So they can use that. And inside the handler, it's called iMessage handler context. So these are 2 distinct interfaces.
Very
the answer
good.
is yes, they can use iMessage session.
Mm-hmm. Another question from Paolo is he asks, will the new async NServiceBus message handling support a concurrency limit throttling?
Yes, yeah. So like I showed in the previous webinar, we have concurrency limitations built in. So you can set, for example, it to 12 messages concurrently, and then NServiceBus will make sure that the endpoint will only handle 12 messages concurrently. Maybe with 1 thread, maybe with multiple threads, but as we've seen in the previous webinar, we no longer talk about threads, we now talk about tasks, and in the domain of NServiceBus, messages being handled concurrently.
That makes a lot of sense. Praveen asks another question, 2 questions. One is, can we prioritize a task? And the other one is, can we name a task for debugging?
No. So, well, you could, but that's really complex. So naming a task is not really possible, but you could create custom schedulers to prioritize tasks. But I would strongly advise not to do it, because as we've seen in the previous webinar, it's really tricky, because then task schedulers float around in the code. You have to make sure that you hide the schedulers in the correct position so that you don't deadlock yourself. I'd say it's not worth the risk.
So I'd say the short answer is no.
Well, possible, yes it is, but I would not advise to do it.
Yeah, makes sense. Another question from Faith. He asks, is there other side effects of the new synchronous API on singleton objects or per request objects like DB context?
On per request, is the question in the handler directly, or I mean, so if they were using the container abstraction API of NServiceBus V5 and they were using unit of work scope still operates the same, since we are creating a new child builder or child container every time we receive a message. So no, there is no implications there. I mean, the singleton implications are still the same. I mean, every singleton that is used inside message handling code needs to be, let's say, concurrency safe.
Yeah, I think that answers the question. I'm not sure how many more questions you want to take, but I have a few more for you, if that's okay.
Okay. Yeah, we can extend, let's say, 2 questions, then we close up, and we can answer the questions in the follow-up blog post or so.
Okay. So Alexei is asking, could you briefly describe what is the main difficulties that you could be faced with during rewriting a non-async to async code? I think you kind of described it in your, yeah.
Yeah, I mean, what we usually see out there in the wild, especially with legacy applications, is the usage of thread static and thread local. That's definitely one. There are a few others, like, for example, you cannot write await keywords in log statements. Of course, manual reset events, monitor codes can be tricky. I'm going to write a series of blog posts together with my workmates here in particular, where we discuss the different problems you could face and a few workarounds and possibilities. Because this would be another topic for a webinar itself. So.
Great. So last question from Blaze again. It is how or why did we choose to not have a suffix of async on the entire API?
Okay. So there are guidelines from Microsoft, or basically the guidelines were there where they said, okay, if you have async APIs mixed with sync APIs, you should basically postfix them with the async keywords, with async, like send async, publish async. We decided not to do that because the whole domain of NServiceBus is IO bound, and all methods which are participating in this IO bound domain are returning a task. So that means we decided it would be just noise, since you can assume that everything called inside message handlers or everything participating that returns a task. So that's why we decided not to use this. By the way, Mass Transit does the same, and a few other async only APIs do the same.
Great, thank you.
Sean,
yep.
Sean, let me iterate on the second last question briefly. I think I just want to restate that when I talked about log statements, monitors, manual reset events, and thread local and thread static, it's important to understand that this is not something which is bound to NServiceBus. You are going to face these problems when you're using async await enabled APIs in your code. So independent from NServiceBus, if you want to leverage the async APIs and you have existing code, you will stumble over these problems. That's important to add. But we try to provide as much guidance as possible around that.
Yeah, I think you showed, also kind of pointed that out through the previous couple of previous webinars. So, yeah, thanks a lot.
So that's it for today. Thank you very much, and hopefully see you next time. Bye-bye.